Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider. You are watching Learn and Teach by Sir Ayaz. So I will continue my video for past papers, and for this video session, I'm doing 0620 and the variant is 61. It's of May-June 2023. You all are aware of it that it's paper 6, that is alternative to practical. So instructions that you have to answer all questions. You need to use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. You should show all your working and use appropriate units. Information for this paper is total mark for this paper is 40. The number of mark for each question or part question is shown in brackets. Notes for use in qualitative analysis are provided in the question paper. These are the notes for use in qualitative analysis. Here is the list for the test of anions. Then you have a list for aqueous cations. Then you have test for gases. Last but not least, flame test for metal ions. So let's continue the paper. Question number 1. Ethanol can be made by fermentation of sugars found in plants. A byproduct of fermentation is carbon dioxide gas. A student made some ethanol using the following method. Step number 1. Cut up some sugarcane and crush it. Step 2. Add hot water to the sugarcane and stir to dissolve the sugar in the sugarcane. Step 3. Remove the solids from the mixture to obtain sugar solution. Step 4. Let the sugar solution cool and then add yeast. Step 5. Place the mixture obtained in the mixture shown in figure 1.1. Leave the apparatus until fermentation is complete. So here's the apparatus, figure 1.1. You have sugar solution and yeast here, and then you are having on the right hand side, it's definitely collecting some gas, and it's tested using lime water. A. Name the item of apparatus labeled A in figure 1.1. It's very easy. It's known as conical flask. So you write conical flask. B. Explain why hot water rather than cold water is used in step 2. Definitely sugar will dissolve faster in hot water than in cold water. So you write sugar dissolves faster. Number C. Name the method used to remove the solids from the mixture in step 3 and draw a diagram to show how this is done. So name of process is filtration. Now here you need to draw diagram for the apparatus used in the space provided. So the apparatus will be like this. You have to show the paper here. Moving to next part. D. State why the sugar solution is allowed to cool before the yeast is added in step 4. Now yeast contains an enzyme, zymase, which acts at a temperature range between 25 to 35 degrees centigrade. and at higher temperature it becomes denatured or it does not function. So you write enzymes denatured. At higher temperature. Fermentation occurs between take place between 25 degrees centigrade and 35 degrees centigrade. E. Describe how the appearance of the lime water changes as fermentation takes place. Coming back to the question, now they have mentioned in the question that carbon dioxide gas is produced. So definitely here you are having bubbles of carbon dioxide. So you will have bubbles of carbon dioxide here. And it will definitely turn this lime water from colorless to milky. If you didn't remember the test, you can simply go to the qualitative analysis and look at the test for carbon dioxide gas. Here's carbon dioxide gas, and this is the test, turns lime water milky. Number F, describe how the solution could tell that fermentation is complete. So definitely there will be no bubbles in lime water once the fermentation is complete. G, name the process used to separate ethanol from mixture obtained by fermentation. In the fermentation, what you will get? You are getting ethanol plus water because ethanol is produced in the solution, which is water. So you need to remove the ethanol from water. Both the ethanol is miscible in water. Both of these mix in each other into each other. So fractional distillation is a process used to separate these. So you write fractional distillation. Moving to next question, question number 2. A student investigates the reaction between aqueous ammonia and two different aqueous solutions of copper 2 sulfate labeled A and B. Solutions A and B have different concentrations. The student does two experiments. Experiment 1, fill a burette with solution A, run some of solution A out of the burette so that the level of solution A is on the burette scale, and record the initial burette reading. Use a measuring cylinder to pour 25 centimeter cube of aqueous ammonia into a conical flask. Stand the conical flask on a white tile. Slowly add solution A from the burette to the conical flask while swirling the flask until the mixture in the conical flask just starts to become cloudy. Swirling means mixing. Record the final burette reading. Experiment 2. Empty the conical flask and rinse it with distilled water. Empty the burette and rinse it with distilled water. Rinse the burette with solution B. Repeat experiment 1 using solution B instead of solution A. A. Use the burette diagrams in figure 2.1 and figure 2.2 to complete table 2.1. So we are having experiment 1. Here we have initial reading and final reading for experiment 1. Here we have experiment 2. Here we are having initial reading and final reading for experiment 2 in figure 2.2. Now we need to complete this table using the readings. So for experiment 1, the initial reading is 1, 2, 3, 4, 5, 6. Here it's 0.6. What about the final reading? 18.123. So final reading will be 18.3. This is for experiment 1. So I will write 18.3 and 0.6. Now you will subtract 0.6 from 18.3. You will get 17.7. So I will write 17.7 here. What about experiment 2? Initial reading 9.12. So you'll write 9.2 as initial reading for experiment 2. What about final reading? It's exactly 21. So we have 21 as the final reading and 9.2 as the initial reading. Now subtracting 9.2 from 21, we will get 11.8. Here we have 11.8. B. Explain why a white tile is used during the titration, so that the student can clearly see the color change. So that the student can see the color change easily. Part C. In experiment 2, the burette and the conical flask are both rinsed with water. The burette is then rinsed with solution B. 1. State why both the burette and the conical flask are rinsed with water. It's very simple to clean it or to remove solution A. To remove solution A, or you can even write to clean it. Number 2, explain why the burette is then rinsed with solution B. Now this time we want to remove water. So you write to remove water. Number 3, describe how the result of experiment 2 would be different if the conical flask is rinsed with aqueous ammonia after rinsing with water. In this case, then you will need more solution B, as there will be more than 25 centimeter cube of aqueous ammonia in the flask. So you write more solution B will be required. As there will be more than 25 centimeter cube of aqueous ammonia in the flask. Next part, D1. Deduce which solution of copper 2 sulfate, A or B, is more concentrated. Explain your answer. the one which needs less volume. So it must be solution B. As you can see, less volume will be needed here. So you'll write solution B. Because smaller volume of titer is needed. Number 2, deduce how many times more concentrated this solution of copper 2 sulfate is than the other solution of copper 2 sulfate. Look at the readings. We have 11.8 and 17.7. So what I will do, I will divide 17.7 by 11.8 to show that how many times more concentrated. 17.7 is the large volume needed and 11.8 is the less volume needed. So it's 1.5. The answer is 1.5. E. Describe how the reliability of the results obtained can be checked. So repeat this experiment and you can compare the results. Repeat experiment and compare the results. F. Deduce the volume of solution A required when experiment 1 is carried out with 10 centimeter cube of aqueous ammonia. Now, this time, what the student is doing, he is using 10 centimeter cube of aqueous ammonia instead of 25 centimeter cube of ammonia. So what is the titer value in experiment 1? In experiment 1, you have 17.7 as a titer value. So 17.7 for 25 centimeter cube. 17.7 is needed for 25 centimeter cube. X centimeter cube will be needed. This is volume of titer. Volume needed for 10 centimeter cube of ammonia. So X becomes equals to 10 multiplied by 17.7 divided by 225. Divided by you will get 7.08. 7.08 centimeter cube will be needed. G. In experiment 1 and 2, the volume of aqueous ammonia is measured using a measuring cylinder. Give an advantage and a disadvantage of using a volumetric pipette instead of a measuring cylinder to measure the volume of aqueous ammonia. Now, what will happen if you will use volumetric pipette instead of measuring cylinder? Definitely, it's having a higher accuracy. So you write higher accuracy. What about the disadvantage? In disadvantage, it will takes more time. Moving to next question. Question number 3, a student tests two solids, solid E and solid F. Test on solid E. Table 3.1 shows the test and the student's observations. Here's table 3.1. Test 1, gently heat half of solid E in a boiling tube. Observations, a solution forms, steam is given off and condensation forms at the top of the tube. Test 2, dissolve the remaining solid E in water to form solution E. Divide solution E into 3 portions. To the first portion of solution E, add aqueous sodium hydroxide dropwise and then in excess. A brown precipitate forms which remains when excess is added. Test 3, warm the product of test 2 and test any gas produced. In observation, the gas turns red litmus paper blue. Test 4, to the second portion of solution E, add 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. In observations, no change. Test 5, to the third portion of solution E, add 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. White precipitate is obtained. A, state what conclusion can be made about solid E from the observations in test 1. So coming to the test 1, here's a test 1. Student gently heat half of solid E in a boiling tube. If solution is formed, steam is given off and condensation formed at the top of the tube. So it's steam is produced. Steam indicates that water is released. So it must be hydrated or contains water. Hydrated or contain water. B, identify the gas produced in test 3. Where's test 3? Here's test 3. Warm the product of test 2. Now they have warmed the product of test 2 and test any gas produced. The gas turns red litmus paper blue. So which gas turns red litmus paper blue? So you see, it's ammonia. Turns damp red litmus paper blue. So you write ammonia or NH3. Ammonia or NH3. C, state what conclusion can be made about solid E from the observations in test 4. Here's test 4. Now they have added in the second portion of solution E 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. There's no change. So this test is used. Coming back to the test, if you look at the test, here's the test using aqueous silver nitrate followed by dilute nitric acid. And this test is used for testing these ions: chloride, bromide, iodide. These are halide ions. So the change is no change. The observation is no change. So what we will write, it does not contain halide ions. Solid does not contain halide ions or name ions. You can write the name of the ions: chloride, bromide, iodide. D, identify the 3 ions in solid E. Now looking at these test and observations, if you look at the test 2, what does test 2 indicate? In test 2, they are writing aqueous sodium hydroxide dropwise and then in excess. And we are getting brown precipitate, which remains when excess is added. So here's a test is a test for the cations. In the cations, you see after adding sodium hydroxide, Fe3 plus gives a red-brown precipitate which is insoluble in excess. So you have Fe3 plus here. One of the ion must be Fe3 plus 3 of Fe3 plus. Now warm the product of test 2. Now they are warming the product of test 2 and test any gas produced. Gas is turning red luminous paper blue. Coming back to this test for cations list, for the test of cations again, you will see here it's ammonium ion, ammonia gas, which produces ammonia gas on warming. And test for the ammonia gas, here I have already mentioned, turns damp red litmus paper blue. So it must contains ammonium ion. Second ion must be ammonium. So you write ammonium, NH4 positive. And the last ion, if you look at this, there won't be any change for the test 4. What about test 5? In test 5, they are adding dilute nitric acid followed by a few drops of aqueous barium nitrate, and white precipitate is produced. If you look at the ions, list of the anions. So after adding dilute nitric acid, when aqueous barium nitrate is added, white precipitate is produced. It indicates the presence of sulfate ion. So sulfate must be the third ion present, and SO4 minus 2. Alternatively, you can write the name of these ions or name the ions. Test on solid F. Solid F is zinc sulfide. Complete the expected observations. The student dissolves solid F in water to form solution F. The student divides solution F into 3 portions. A. To the first portion of solution F, the student adds aqueous ammonia dropwise until it is in excess. Observations during adding dropwise, observations in excess. Now, this must be the test for the presence of zinc ion. So, zinc is the cation. Here is the list of cations. Where is zinc? Here is zinc. What they have added? They have added aqueous ammonia. And it must form white precipitate. It dissolves or soluble in excess to form a colorless solution. So you'll write white PPT. White PPT is produced, white precipitate. Obtained observations in excess, dissolves in excess, dissolves. Or you can even write or forms a colorless solution. Forms a colorless solution. F. To the second portion of solution F, the student adds a few drops of acidified aqueous potassium manganate 7. They are asking about the observations. The solid is zinc sulfide. The sulfide means SO3 minus 2. So if you look at the list, here is sulfide, SO2 minus. It can be tested by adding a small volume of acidified aqueous potassium manganate, and the solution changes color from purple to colorless. So definitely what you write here. You write decolorized. Decolorized or purple solution becomes colorless. G. To the third portion of solution F, the student adds 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate. If you look at the salt, it's zinc sulfide. There isn't any sulfate ion present. This is sulfate ion. This is a test for the sulfate ion when you are adding barium nitrate. So what you'll write? You'll write no change. There will be no change. Moving to last question. Number 4, solid cobalt 2 oxide is a base which is insoluble in water. It reacts very slowly with cold dilute sulfuric acid to form a solution of cobalt 2 sulfate. Describe how to make pure dry crystals of hydrated copper 2 sulfate. You are provided with cobalt 2 oxide, dilute sulfuric acid, and common laboratory apparatus. Now, this method involves the reaction between metal oxide and warm or concentrated acid. So you have to warm. You have to warm during this reaction and mention the name of the apparatus you are using. So you can write any six from these because the total mark for this question is 6. So you have to give 6 statements. Any 6 from. So you will add cobalt 2 oxide to dilute sulfuric acid in a suitable container like beaker. Add cobalt 2 oxide to dilute sulfuric acid in a beaker. I am mentioning the name of the apparatus. Next point, that cobalt 2 oxide must be in excess. Cobalt 2 oxide must be in excess. Next part must be you have to stir it, then heat it. Stir the solution. Warm the mixture. Warm or heat the mixture. Now here remember one point. Avoid overheating. Next point, filter. Filter to remove excess or unreacted cobalt 2 oxide. You can mention the name of apparatus using the filter funnel. Filter funnel and filter paper. Next, you will heat the filtrate. Heat the filtrate, but avoid overheating. But avoid overheating. So instead of writing heat the filtrate, you can write gently heat the filtrate. Gently heat the filtrate. The next part will be crystallize. Or you can have drawing, draw in air. Don't write draw in over. Do not write dry in oven, because this may destroy the water of crystallization, which is in this salt. As they have already mentioned, it's a hydrated cobalt 2 sulfate. That's all for this video. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.